Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 840, which is magic squares in grid. Let's see the problem description. A 3 cross 3 magic square is a 3 cross 3 grid filled with distinct numbers from 1 to 9, such that each row, column and both diagonals have the same sum. And given a row cross column grid in grid of integers, how many 3 cross 3 contiguous magic square subgrid are there. Note, while a magic square can only contain numbers from 1 to 9, grid can contain many numbers like from up to 15. Okay, let's see the constraints. Row and column will be up to 1 to 10, and each number in the grid will be from 0 to 15. Okay, so we have to find like how many valid magic squares are there in the given grid. Okay, and every valid magic square will be each number from 1 to 9, and the sum of all row and all column and both diagonals will be the same sum. Okay, this is our main task. So I will create a function which will first validate that each, like, it will take the grid and a position, starting position, and it will check the current, like, 3 cross 3 grid is valid or not. Okay, and I will check it for all the valid position present in the grid and count how many valid magic squares are there. Okay, so let's see. First I will create in uh, answer equal to 0 initially. For int I equal to 0, I less than grid dot size -2. Why -2? Because the up, like, the last index, like the row index will be, like, for this there is only three like rows are there. So 0, 1, 2. If there is more rows will be like 1 to 9, let's say. So the index will be 0, 1, 2 up to 8. So the last valid cube, like, size will be 3 cross 3. So you can imagine, like, this is like n minus 1 row, this is n minus 2, this is n minus 3, and we need to go up to n minus 3, because after that the there we can't make a 3 cross 3 grid. So we have to go up to like n minus 3, and to go n minus 3 I am using less than n minus 2, so it will go up to n minus 3. And I plus plus, and for int j equal to 0, j less than grid 0 dot size j plus plus. And this is also will be, j will go up to less than 2, because the same reason we can't make valid 3 cross 3 grid after that index. So j will be same as that. And we need to find first, I will make a check function which will take the grid, the ith index and j, and it will give us boolean. It will return a boolean which is true or false. So it will give true if the current grid is, like, 3 cross 3 grid is valid magic square. Okay, so then I will just increase the answer by plus plus. That's it, and after that we will return the answer. And now let's see how the check function will be. So it will be return type boolean check, and it will take three parameters, which is, first one is grid, second one is a and b. ABR is the current row index and column index. Okay, first I will create a sum equal to -1, because I need to check all the sums are equal or not, and another is valid numbers or not. So to check valid numbers, I will create a, let's say, vector, and the size will be 10, because we have to check from 1 to 9, and 9 will be the last index. So 9, if the 9 is the last index, then the size will be 10. Okay. Now I will go. First, I will check the row sum, each row sum like this. So to check the row sum, I will be from A, I less than, uh, sorry, I equal to A, I less than A plus 3 and I plus plus. Current, let's say current sum is currently 0, and for each column, we will do J equal to B, J less than B plus 3, J plus plus. So for each column, I will check first if it is valid number or not, because in the grid there can be like 0 to 15 up to numbers. So first I will check if the, let's say, number is n equal to grid of ij. Okay, I will check if n is less than 1 or n is greater than 9, then just return false because it is not a valid number. And then I will check also if VC of n is equal to 1 or not. That means it is already visited or not. If it is already visited, that means we already got one number same as n. So we will just return false because we need distinct numbers from 1 to n, 1 to 9. Okay. And then if it is not, then we will first add VC of n equal to 1 visited, and we will also current plus equal to n, like current sum will be plus equal to n. And after that, we check if the sum is valid or not. To check this, because our sum is initially at -1, so we check if sum is equal to -1, then we do not need to check, we just sum as current. And otherwise, else check, not check, like you can directly return from here. So check if sum is not equal to current or not. If it is not equal to, then directly return false. Okay. And if it is equal to sum, then we do not need to check anything because we already set the sum as current. So that's it. Now we have validated the row sum, and now next task is to validate the column sum. So check column sum first. J will be from B to J less than B plus 3, J plus plus. Current sum is equal to 0 for int I equal to from A, I less than A plus 3, I plus plus. We check. Now we already validate, like if all the numbers are from 1 to n and each number are from 1 to 9 or not. Okay. 1 to, not like each number is 1 to 9 and they are like sum is valid or not. So we do not need to check again because we already, this for loop is already validate the numbers present in 3 cross 3 grid. We do not need to again validate it. We just need to validate the sum. So we'll just current plus equal to grid of ij. That's it. And after that, we need to check if sum is not equal to current. Then just return false because you already, like sum will be already there. So we do not need to check the -1 part. So just check sum is not equal to current. Then now we have validated the row wise sum and column wise sum, and now we need to validate the diagonal sum. To check it, I first create, let's say, d1 equal to diagonal will be grid of AB plus grid of A plus 1, B plus 1, and third one will be grid A plus 2 and B plus 2. like this is the like diagonal AB, A plus 1, B plus 1, and A plus 2, B plus 2. And the second diagonal D2 will be grid of A, B plus 2, because A, B plus 2, and plus grid of, it will be same, A plus 1, B plus 1, and third one will be grid A plus 2 and B. That's it. This will be the two diagonals. And we'll check if D1 is not equal to sum or D2 is not equal to the sum. So then we will just return false, and otherwise return true. Okay, that's it. This function will check if the current 3 cross 3 is valid or not, and our this like nested for loop will check for all the like valid 3 cross 3 grid. So after that we will go and get the count of valid magic square, and we need to return it. Let's say will it work? Okay, there is an error, and I have debugged the code and I found nothing in the logic, but there's this error occurred because I just replace the n equal to grid and use n instead of the grid dot size, and also use m equal to like grid 0 dot size, use m. Yeah, now you will see like it will accept it. So let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. So the check with the 3 cross 3 grid, it is like this for loop is running like 9 times, and this for loop also will be running from 9 times. You can ignore that. You can say it is big O of constant. And for this, it is this two for loop. The overall time complexity will be like big O of n cross m, where n is the number of rows and m will be the number of columns. Okay, this is the time complexity. And space complexity, we are not using any of like array or vector which is depending on the length of the grid. We are just creating a 10 size like array, which is you can say constant space. So the overall space complexity will be big of constant, or you can say big of 1. And I don't know why this gives an error, because I previously I have used like grid like size instead of n and grid 0 dot size instead of n, but I don't know why it is not working. So use n and m instead of this size directly. Do not use that. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.